The purpose of this experiment was to see how much voltage a wind turbine generates at different speeds. So we hypothesized that if the fan is on the highest level speed, which would be 3, then the wind turbine would generate the most energy.
People have been manipulating the power of wind since around 5000 BC, and many people used it for propelling their boats, or people in China used it for pumping water. But more recently, there have been a lot of advances in the way that a wind turbine works, and um, if any of you have ever seen a wind turbine before, it kind of looks like a big giant fan, but it works opposite of a fan because instead of pushing energy out, it takes the energy, or it takes the wind and it converts it into electricity. So if the reason that wind turbines are so high up in the air is because at that elevation there's less turbulent winds, and they're also at faster speeds. And so pretty much how it works is, as you know, like a wind turbine has propellers, and as the wind hits the propellers, it causes them to spin. And the propellers are connected to a rotor in the head of the turbine, and that's connected to a main shaft. So as the blades spin, it makes the rotor spin, and then that makes the main shaft spin, and then the main shaft is connected to a generator. So it's kind of like a domino effect. So as the main shaft spins, it causes the generator to spin, which causes the turbine to make electricity. At the base of the turbine, we had coiled wires that we soldered together, and those were for to allow the flow of electrons that will generate electricity. So pretty much as the wind turbine spins, the magnets on the bottom create an electric current that flows through the coiled wires and then to the generator, which creates electricity.
We took many safety precautions during this experiment because it involved a lot of building and electricity, so we wore safety goggles through the whole experiment to cover our eyes. We carefully worked with the magnets so our fingers didn't get stuck in between them because they were really strong magnets. We took precautions soldering the wires, the electric wires, because it was wrapped and we had to get the wire to be bare. And we watched the hot glue gun from burning anyone or anything when building the wind turbine.
First, to actually complete this experiment, we needed to build a base, and pictures will follow. My dad helped a lot because it was a lot of sawing and cutting. And we basically just built a contraption, if you want to call it that, for the wind turbine to build in, and it was just a regular wooden board with 2 pegs and a crossbar at the top, and the wind turbine fit inside of that.
At the base of the turbine, we had coiled wires that we soldered together, and those were for to allow the flow of electrons that will generate electricity. So pretty much as the wind turbine spins, the magnets on the bottom create an electric current that flows through the coiled wires and then to the generator, which creates electricity.
Our graph shows the effect of fan speed on voltage. The independent variable is located on the y-axis, and it is the fan speed, ranging from slowest to highest, or fastest, and the slowest was the 1. And once we tested that, we got 3.36 millivolts for the slowest fan speed, and that created the most voltage on our graph. The dependent variable, which is seen right here, is the voltages, measured in millivolts.
After doing the experiment, we conclude that the slowest speed of the fan generates the most energy. And this is because the slowest speed of the fan was able to pick up the wind current that was going through the wind turbine to be able to generate energy, and when it's too fast, it's not able to pick it up or read how much energy is being produced.
This experiment was an experiment of trial and error. Originally, the type of wire used didn't work out, so another type of wire was used that was coated and stripped of its coating, so it wouldn't be attracted to the top layer of the magnets spinning above them. Also, we had the screw and the base had to be unscrewed so that the space in between the magnets and the wire was good enough. In future experiments similar to this, copper wire should be used because the attractive force isn't strong and they won't be likely to stick together, the magnets and the electric wire. And also during the third trial of this experiment, the location was moved and because of a power outage, and this could have affected the distance between the fan and the wind turbine, and also maybe it could have affected the wind speed a little bit because of the direction of the fan.